Today, we're tackling a problem that seems simple, checking if two collections of strings are equivalent. But there's a catch. Can you do it without building new, potentially massive, intermediate strings? Let's dive into the challenge. Given two string arrays, word1 and word2, we need to determine if concatenating all strings in word1 results in the exact same string as concatenating all strings in word2. For instance, if word1 is a C and word2 is a BC, both form ABC, so the answer is true. The core task is to compare these virtual long strings. The most straightforward approach is to simply concatenate all strings in word1 into a single string, do the same for word2, and then compare the two resulting strings. This works correctly. However, it's not ideal for memory. If the input arrays contain many long strings, creating these two new, potentially very long strings consumes significant auxiliary space. This gives us a time complexity of big O of n, where n is the total number of characters, and also in big O of n space complexity for storing the concatenated strings. The key insight for an optimal solution is to compare characters directly without forming full intermediate strings. We can use 4 pointers, 2 to track the current word index in each array, and 2 more to track the current character index within those words. We iterate, comparing characters one by one. If at any point the characters don't match, we immediately return false. After comparing a character, we advance its character pointer. If a character pointer reaches the end of its current word, we reset it to 0 and advance the word pointer to the next string in its array. We continue this process as long as both word pointers are within their respective array bounds. Finally, we return true only if both word pointers have reached the end of their respective arrays, indicating all characters matched. Let's trace this with word1 as a C and word2 as a BC. Initialize word pointers I1, I2 to 0, and character pointers J1, J2 to 0. First, we compare word1 at I1, J1, with word2 at I2, J2, They match. Advance J1 and J2. Now, word1 at I1, J1, B, compares with word2 at I2, J2, B. Match. Advance J1, J2. J1 is now at the end of a, so we increment I1 and reset J1 to 0. J2 is also at the end of a, so we increment I2 and reset J2 to 0. Next, word1 at I1, J1, C, compares with word2 at I2, J2, C. Match. Advance J1, J2. Both J1 and J2 are now at the end of their respective current words. We increment I1 and I2, resetting J1 and J2. Both I1 and I2 have now reached the end of their arrays. The loop terminates. Since both I1 and I2 successfully reached the end of their word arrays, it means all characters matched. Therefore, the function returns true, correctly indicating that the two string arrays are equivalent. You'll spot this two-pointer pattern when you need to compare elements from multiple collections or nested structures, but want to avoid creating large intermediate data structures. It's particularly useful when dealing with virtual sequences that are logically combined from smaller parts, and you need to compare them character by character or element by element. The time complexity is big O of n, where n is the total number of characters across all strings. The space complexity is big O of 1, constant time, because we only use a few pointers. This two-pointer technique is incredibly versatile. Try applying the same pattern to other problems involving comparing flattened views of nested data. Don't forget to like and subscribe for more efficient algorithm breakdowns.